Hey everyone, today I'll be showing you how to solve rational expressions, rational equations, and rational inequalities. So let's first discuss how to solve rational expressions. In rational expressions, what are they? So, a rational expression is the quotient of two polynomials with the denominator of 0. So we have here a guide of P over Q, such that P and Q are polynomials with Q is not equals to 0. So examples of rational expressions are 4x minus 5 over 7 and 2x minus 1 over x plus 4. So the first topic that we need to discuss here is reducing a rational expression to lowest terms. A rational expression has been reduced to lowest terms if all common factors from the numerator and denominator have been cancelled. So for our first example of rational expression is x minus 2 over x minus 2 and x plus 3. So in this rational expression, you can see there is a common factor in both the numerator and the denominator. So if ever you see a common factor, it means you can cancel it, which makes the final answer as x over x plus 3. One thing you have to keep in mind is that you cannot cancel unless the term is being multiplied by another term. So example, if we say that x plus quantity x minus 2 over here, you cannot cancel it since it's addition. But since over here, it's multiplication, that means you can cancel it. Another example would be 35x to the fifth over 49x squared. So this can be simplified. So a common factor that we can divide by both is is 7. So divide by 7. 35 divided by 7 is 5. Copy x to the fifth. 7 divided by 49 is 7. Copy the x squared. So we can also factor the variables over here, x to the fifth and x squared. So when dividing with common base, you must subtract the exponents, 5 and 2. So when you subtract them, it would be 5x cubed over 7. So this would be the final answer. Another example would be 4x squared plus 8x over 3x plus 6. So in this rational expression, you can factor this by the greatest common factor. The greatest common factor over here would be 4x. So 4x divided by 4x squared would be x. And 4x divided by 8x would be 2. In the denominator, we could bring out 3. 3 divided by 3x would be x. And 3 divided by 6 would be 2. So you can see here, we can cancel out x plus 2, which would make the final answer 4x over 3. So for our next example, let's have x squared minus 2x minus 8 over x squared minus 9x plus 20. So over here, the numerator and the denominator are both quadratic trinomials, which means we can factor this even more. So in factoring this, we must find a value so that when it's multiplied, it would be negative 8. So what are those two numbers? When multiplied, it will be negative 8, but when added to each other, it would become negative 2. Let's try negative 4 and 2. Negative 4 multiplied by 2 is negative 8, and negative 4 plus 2 would become negative 2. So we can use both. So we can say x minus 4 and quantity x plus 2. So let's go to the denominator. So we need to find two values that when multiplied it would become 20, but when added to each other it would be negative 9. So in here you can see that there is a common factor between the numerator and the denominator. We can cancel out x minus 4, which makes the final answer x plus 2 over x minus 5. You cannot further simplify this. So that is how you simplify rational expressions. So now let's move on to simplifying rational expressions when there's addition, subtraction, multiplication, and division. So let's have 4 over x minus 2 plus 5 over x plus 2. So in simplifying rational expressions with addition or subtraction, they must first have a common denominator, and if they don't have a common denominator, we must find those first. So we can see over here that x minus 2 and x plus 2, to find those common denominators, we must multiply it by each other. So x minus 2 multiplied by x plus 2 would be the LCD. So x minus 2 quantity and x plus 2, when divided by x minus 2, we would cancel both the common factor, which would only leave x plus 2. So that means 4 multiplied by x plus 2. Add. So x minus 2 multiplied by x plus 2, when divided to x plus 2, we will cancel the x plus 2, which would only leave x minus 2. And x minus 2 multiplied by 5 over here. So let's distribute it. 4x plus 8 plus 5x minus 10 over x minus 2 and x plus 2. Add like terms, it would become 9x minus 2 over x minus 2 and x plus 2. This would be our final answer. So let's have another example. X over x squared plus 9x plus 20 minus 4 over x squared plus 7x plus 12. So when we factor this out, this would become x plus 5 and x plus 4. When we factor out this one, it would become, x plus 4 and x plus 3. So when we're looking for the common denominators, if they are repeated factors, we should only just include just one of them. So the least common denominator would be x plus 5, x plus 4, and x plus 3. So when we divide the LCD with the denominator of this one, we would get x plus 3. We would get x multiplied by x plus 3 minus, if we multiply this term over here, we would get 4 multiplied by x plus 5. And this would turn out as x squared plus 3x minus 4x minus 20 over x plus 5, x plus 4, and x plus 3. So let's add like terms. It would be x squared minus x minus 20 over x plus 5, x plus 4, and x plus 3. So as you can see here in the numerator, this can be further simplified. It can be x squared minus x minus 20. And we need to find a factor which, when you multiply them, it would be negative 20, and when you add them, it would be negative 1. So we can say negative 5 and 4. So we can make x squared minus 5x plus 4x minus 20. We can group them and bring out their common factor, which is x minus 5, plus 4, we can bring out 4, leaving x minus 5. Is there common? We can bring out x and 5, and x plus 4. Now let's add this to here. X minus 5 and x plus 4 over x plus 5, x plus 4, and x plus 3. We can cancel out here x minus 5, x plus 4, and x plus 4. Which leaves us with the final answer, x minus 5 over x plus 5 and x plus 3. So now let's move on to multiplication and division of rational expressions. So for my first example, it will be 2x cubed plus 18x squared over x squared plus 2x minus 8 multiplied by x squared minus 4 over 8x squared plus 12x. So as you can see here, all of the polynomials in these rational expression can be factored out. Over here, we can factor out 6x squared, which leaves 2x plus 3. And in its denominator, this can be factored out into x plus 4 and x minus 2. Over here, this can be factored out into the difference of squares, which will be x plus 2 and x minus 2. Over here, we can bring out the term 4x, which leaves x plus 3. 2x. So let's start cancelling out. You can cancel out 2x plus 3 over here and over here. You can cancel out x minus 2 and x minus 2, which leaves the terms x squared and x plus 2 over 4x and x plus 4. So over here, you notice that you can still further simplify this. And simplify it by dividing it by 2. So over here, it would be 3x squared and x plus 2. Over here, it will be 2x and x plus 4. But you can still further simplify it by dividing it by x, which leaves it 3x, quantity x plus 2, over 2, quantity x plus 4. And this would be our final answer. Now let's move to our next example, which is m squared minus 9 over m squared plus 5m minus 6 divided by m minus 3 over m plus 2. So both of these polynomials may be simplified into m plus 3 and m minus 3 over m plus 3 and m plus 2. And when dividing by another term or an expression, you must reciprocal it if we want to multiply. So m plus 2 over m minus 3. Let's start cancelling out. So we can cancel over here m minus 3, over here 2, m plus 2, and also m plus 3. So that means we cancelled all of the factors out, which leaves us with 1. Now let's move on to rational equations. First of all, a rational equation is an equation containing at least one rational expression. So let me give you some examples. So for our first example, it would be 5 over x minus 1/3 equals to 1 over x. So a rational equation should always have an equal sign. And if there's no equal sign, that means it's not an irrational equation. So in solving it, first thing we have to do is to multiply both sides by the LCD. So the LCD would be 3x. So we multiplied 3x to the whole equation. It would be 3x divided by x would be 3, multiplied by 5 would be 15. 3x divided by 3 would be x, and x multiplied by 1 would be x. Equals 3x divided by x would be 3, multiplied by 1 would be 3. So now, let's isolate x. Negative x equals to negative 15 plus 3. So negative 15 plus 3 would be negative 12. Divide both sides by negative. The answer would be x equals to 12. So let's have another example. 1 over x, quantity x plus 1, equals to 3x plus 1. So first, we need to multiply both sides by the LCD, which would be x quantity x plus 1. X quantity x plus 1 multiplied by x quantity x plus 1 and 3x plus 1 will also multiplied by x quantity x plus 1. So x quantity x plus 1 divided by x quantity x plus 1 would be 1. And 1 multiplied by 1 would be 1. So 1 equals to x quantity x plus 1 divided by x plus 1 would be x. And x multiplied by 3 would be 3x. So we can just simply interchange them, would be 1. So divide by 3. This would leave us with x equals to 1/3. Now, let's move on to rational inequality. So in rational inequalities, a rational inequality is an inequality that contains a rational expression. And inequalities can be with the signs of greater than, less than, greater than or equal to, or less than or equal to. So here, let's have the first example. X plus 2 over x plus 3, greater than or equals to 0. So let's start with the number line. So first of all, we need to find values that we can plot in the number line, and we can use the numerator and the denominator. So let's equate them both to 0. So x plus 2 equals to 0, which will become x equals to negative 2. And the denominator, x plus 3 equals to 0, which will make it x equals to negative 3. So let's plot it here in the line. Negative 2 and negative 3. To the right, we have positive infinity and negative infinity. So notice over here that in the denominator, we have x plus 3. And you know that in rational expressions, the denominator must not be equals to 0. So that means x must not be equals to 0. And in the number line, we would leave an open circle. And in the numerator, it's fine if we put a 0. So we'll put a closed circle. Make sure you remember that. Since this expression over here must be greater than 0, it means we're looking for positive numbers. So there are 3 main regions that we have over here in the number line. This one, over here, and over here. So we must determine the signs of each region in order to know which set of values is okay for us to use in this inequality. So let's try a number from this side of the region. So let's try -1. If we have -1 in the numerator, it would be -1 plus 2, which would make a positive sign, which means positive 1. And -1 plus 3 would be positive 2, which would say positive. So this positive divided by a positive would always be equals to a positive. So this region over here would be a positive sign. So next, let's have a number over here. So let's say -2.5. So -2.5 plus 2 over here, it would be -0.5. So it would be a negative sign. Over -2.5 plus 3 over here would be a positive 0.5. So negative divided by a positive would be a negative. So this region over here would be a negative. Well, this region over here, let's try -4. So -4 plus 2 over here would be -2, mean a negative sign. And -4 plus 3 over here would be -1. So negative divided by negative would be positive. So this region would be a positive. Now we want the fraction to be greater than or equals to 0. That means we're looking for a positive region. So we're going to shade this region and this region as well. So the solution in interval notation would be quantity -infinity and -3. We'll put a parenthesis over here since we're not going to include the -3. With a union of a bracket since we're including -2 and positive infinity. So this would be the interval notation, which means the answer for this inequality. So let's have another example. So let's have x plus 2, x minus 3, over x plus 1, less than 0. Let's start with the number line. So if we equate this to 0, it would be x equals to 3. And if we equate this to 0, it would be -2. And if we equate this to 0, it would be -1. So since this is in the denominator, this would have an open circle. This is the positive infinity, and this is the negative infinity. And since it's a less than, all of these points would have an open circle. But if this would be a less than or equals to 0, these 2 points over here would be closed circle. But this would still be an open circle since it's in the denominator. So remember that if it's a less than or equal to, these would be closed. But if there's no one equal over here, that means it would be left open. So since it's less than 0, we're looking for negative regions. We have 1, 2, 3, and 4 regions over here. So let's start from here. Let's try 4. So 4 plus 2 would be 8, and 4 minus 3 would be 1. So 8 multiplied by 1, it would be 8. So it's a positive. Over 4 plus 1, which is a positive. Positive divided by positive is a positive. So this region would be positive. Next, let's start over here. Let's think of, 0. So if 0 plus 2, it would be 2. And 0 minus 3, it would be -3. 2 multiplied by -3 would be -6. So it would be a negative sign. And 0 plus 1 would be a positive. So negative divided by positive would be a negative. So this region over here would be a negative. So let's try over here. Let's see -1.5. So -1.5 plus 2 would be a 0.5, which is positive. And then negative 0.5 multiplied by 3 would be a negative. So negative multiplied by a negative would be negative, a negative sign. So negative 0.5 over here plus 1, it would be a negative 0.5. So it's a negative. Negative divided by negative is a positive region. So let's try negative 4. So negative 4 plus 2 would be negative 2. And negative 4 minus 3 would be negative 7. So a negative multiplied by a negative would be a positive. And negative 4 plus 1 would be a negative sign. Positive divided by negative would be negative. So this region over here would be negative. And since we are looking for a negative region, we will consider this and this region. So let's do our interval notation. Parentheses, negative 8, negative infinity to negative 2, since open circle, leave it as parentheses, with a union of negative 1 and 3. So this will be our answer.